right, so today we are going to be talking about covalent compounds and types of covalent bonds. So our learning targets, we want to identify properties of covalent compounds and then describe how and which bonds are formed. All right, we're going to start off by talking about covalent bonds. So a covalent bond is formed by the sharing of electrons. Notice how this is very different from the ionic bonds that we talked about. So ionic bonds were when we were actually transferring an electron from one atom to another. That was going to form that ion that was going to hold the two atoms together by that electrostatic force. With a covalent bond, these sharing of electrons are really going to be like a tug of war for the electrons between the two atoms. And sometimes one atom might be stronger than the other in pulling electrons towards it. So remember when we talked about electronegativity, that is something that we're going to come back to today in this lesson. So the unequal sharing of electrons will lead to a type of covalent bond called the polar covalent bond. So this is when two atoms are not equally sharing their electrons. So we have this little analogy here with money. So obviously this guy is getting more money than this guy in this picture. With atoms and bonds, remember that they are competing basically for those electrons that are being shared. So if this guy here is getting more electrons, remember he's pulling a negative charge towards him, and we say that he has a partial negative charge. So he's pulling the electrons towards him, so he has more control over the electrons. Whereas this atom is going to have a partial positive charge because basically electrons are being pulled away, and when we remove electrons, remember, we become more positive. With a nonpolar covalent bond, that is when we have the equal sharing of electrons between the two atoms. So both atoms have the same amount of control over those shared electrons. So generally, we think of a nonpolar covalent bond when these two atoms are exactly the same, because there's not going to be any difference in who wants an electron more. With a nonpolar covalent and that equal sharing of electrons, notice that there are going to be no partial charges because they are sharing them equally. Okay, so covalent compounds. Another name for a covalent compound, you might also see it referred to as a molecular compound, and that's because these compounds are going to be composed of molecules, and we'll get into what a molecule is in just a second, but this might be something that you know from your previous science classes. So if I look at this picture here, I see that I have a molecule being pointed at, and then this whole thing is being referred to as the molecular compound. So you can kind of guess what a molecule is compared to the molecular compound just by looking at this picture. So the compound is obviously going to be made up of more than one molecule. It's going to be several molecules together, and that's going to be our molecular compound. A molecule is just this one unit. And this is going to refer to a neutral group of atoms joined together by covalent bonds. So this one molecule of water here is going to be joined together by covalent bonds between your oxygen and your hydrogens. Generally, all of the elements that are in a molecule are going to be nonmetals and/or metalloids that are bonded together. Generally, we say that covalent compounds and covalent bonds are composed of nonmetals. These molecules can form compounds, which means that there is more than one type of element. So if we think of like the molecular compound water, we know that it has hydrogen and oxygen. Molecules can also form pure elements. So if I think in terms of diatomic molecules, those are referring to singular elements because they are only comprised of one type. So an example would be hydrogen. So hydrogen is a diatomic element. It's always going to exist in nature, bonded to another hydrogen. And since it is only one type of element, it is technically an element and not a compound. So some other examples of molecules, here we have carbon monoxide. So we have carbon with a triple bond to oxygen. Here, this one is glucose. So you learned about that last year in biology. So glucose, remember that we need to take in glucose for energy for our cells. Water is another molecule that we obviously just talked about. So here we have our water molecule. And then this is an example of one of those diatomic elements. So iodine is a diatomic element, so it's going to exist in nature bonded to itself. You can see that we have a couple different models here that are represented in these examples. So these are called ball and stick models. This is going to be a linear shape because it's just going to be like a two-dimensional shape. This is going to be a 3D model. This is going to be another model, so we can do our balls or our atoms kind of just bonded together as we see here and here. And then we have that ball and stick here again for iodine. So I just want you to recognize that there are several different ways that you can show a molecule or molecules for chemistry. Sometimes we have simple molecules and sometimes they are more complex, such as glucose. And a couple other things that you do need to know. So memorizing these covalent common names and formulas. So you might have talked about this a little bit when you did naming, but remember that NH3 is referred to as ammonia and CH4 is methane. All right, and then going back to those diatomic elements. So there are going to be 7 diatomic elements. We have hydrogen, oxygen, nitrogen, and then we have all of the halogens, so fluorine, chlorine, bromine, and iodine. So all of these are going to exist in nature as diatomic, so their formulas are going to have a 2 subscript to show that. All right, so we've already talked about the different types of covalent compounds or covalent bonds. So we talked about how we have a nonpolar covalent bond and a polar covalent bond. And this kind of brings us to this discussion about polarity. So polarity is going to arise from the difference in electronegativity between the elements in the bond. So recall that electronegativity is the amount of attraction an atom has for the electrons of another atom. I kind of refer to it as like how bad an atom wants electrons. So we can look at electronegativity charts to show us the relative electronegativities between the different elements. Remember that fluorine was going to be our most electronegative element, and the noble gases, they're happy with their full outer shells and they're not going to want anyone's electrons. Looking at a couple different diagrams showing this polarity. So remember that our nonpolar covalent bond is going to be the equal sharing between electrons in that bond. So there's not going to be any charges or partial charges on your atoms. Generally, you're going to see that these 2 atoms in the bond are going to be the same. So there's not going to be any difference in electronegativity there. With a polar covalent bond, remember that it's going to be electrons being shared unequally between the 2 atoms, and that would arise to partial charges on your atoms. So if I actually looked at my electronegativity differences, I would look at chlorine, which has an electronegativity of 3, and I would subtract the electronegativity of hydrogen, which is 2.1. All right, so that's going to give me a difference of about 0.9. So that difference then can be kind of correlated to this chart, which is not always conclusive. So don't think that this is like the end-all be-all of saying if it's a polar or non-polar covalent bond. But it does help us categorize those. So really, this is one big continuum. Our bonds don't say, okay, I'm ionic, I'm covalent, but we can kind of categorize them as being nonpolar covalent, polar covalent, and then obviously ionic is like super duper polar because you are completely transferring your electrons there. So with these covalent bonds, you can see that our value that we got for the difference in electronegativity was 0.9, which puts us into this polar bond category here. As we said, the ionic bond was the complete transfer of one or more valence electrons. So like for this example, sodium really wanted to get rid of his electron. Chlorine really wanted that electron. The electronegativity difference is going to be pretty large, and that would put us into this ionic bond area. So basically summarizing, this polarity, so saying if a bond is polar or nonpolar, is going to be due to the difference in electronegativity between the elements in the bond. All right, so we previously talked about properties of ionic compounds, some properties of covalent compounds. So they're going to be relatively weaker bonds than those ionic bonds are. Generally, they're going to be gas or liquids at room temperature. They're going to have lower melting and boiling points, and they do not, under any conditions, conduct electricity in any form. So whether they are dissolved in water or in their general state at room temperature, these are not going to be conducting electricity. So at this point, we talked about ionic bonds and covalent bonds, ionic compounds and covalent compounds. So as a checkpoint, you, for your assignment, are going to be making a Venn diagram for ionic and covalent compounds. So I want you to think about some similarities and differences between them. So like what kinds of elements make them up, what's going on with the electrons in each of the bonds, the electronegativity differences in the bonds, the singular units for each. So what's the singular unit for a covalent compound versus an ionic compound? The strength of the bonds relative to each other, strength of the melting and boiling points and how they relate to each other, the states at room temperature, and then conductivity. So if you could take some time to do that, remember, ask if you have any questions about any of the differences between ionic and covalent compounds.